today, we are the group 4 from this FAS 2C and we will going to present our gathered data from the two markets that we've been interviewed. So, we have 30 respondents from different kinds of market, which was in Panabo Public Market and Carmen Public Market.
We have two variables that we use to finalize our data, and that is quantitative and qualitative, wherein represent tables and graphs as we know later.
First, we will going to discuss our quantitative and then the qualitative data through those tables and graphs as they stated earlier.
So guys, competition of data will be followed soon as we go further.
Here is our quantitative data, and the respondent question was how much do they spend their money to supply their daily needs. And here's the table, wherein comprises the following: class interval, class boundary, class mark, tally, frequency, cumulative frequency, and percentage. So we will discuss first our class interval. Our class interval here is 100, since it is our minimum value and our maximum value is 1,500, as well as our approximated class width or ACW, which is 151. So we will going to start as 100, 100 to 250, 251 to 401, 402 to 552, and so on till it will come to an end of 1,459 to 1,609. So our next is class boundary. In our class boundary, they have two limits, which is lower limit and upper limit. Then our lower limit here is 19.5, then our upper limit is 250.5. So in our lower limit, which is 99.5, we're going to subtract it as 0.5. Then to our upper limit, which is 250.5, we will going to add it as 0.5. So 99.5 to 250.5, 250.5 to 401.5, then 401.5 to 552.5, and so on till it will come to 1,458.5 to 1,609.5. So class mark. Before we're going to get the class mark, we will going to add the class boundary, then divided it by 2. So our class boundary is 99.5 plus 250.5 and divided it by 2 is equals to 175, and that is our class mark. 250.5 to 401.5 is 326. 401.5 to 552.5 is 477, till it will come to 1,458.5 to 1,609.5 divided it by 2 is equivalent to 1,534, and that is the end of our class mark.
Here is the tally of our quantitative data. The class interval of 100 to 250 had a tally of 4. The class interval of 251 to 401 had a tally of 10. Class interval of 402 to 552 had a tally of 8. And in the table, the class interval of 407 to 854 don't have a tally because there is no number of data that belong to this group. The same with the class interval of 1006 to 1156 and 1308 to 1458. And the tally of class interval of 1459 to 1609 is 3. The frequency interprets the result in tally. Cumulative frequency. We just copy the frequency, then added it by 10 in the frequency, then the result added again the next frequency of 10, then do it until the last number or sum. Percentage. The percentage of class interval 100 to 250 is 13.33%. And then the 251 to 401 class interval had a 33.33%. And then the 402 to 552 class interval had a percentage of 26.67. And then the lowest percentage is 0. The 704 to 854, and then the 1006 to 1156, and 1308 to 1458 as well. And it had a total of 100%. In the cumulative percentage, the same with what we have done in the cumulative frequency. We just copied the 13.33%, then added it by the percentage of 303.33, and then the sum or the answer is added again what the next percentage had written in the table till it comes into the sum of 100 percentage.
This graph that we use in quantitative variable is histogram. A histogram is an alternate way to display the distribution of quantitative variable. Histograms are particularly used of large dataset. A histogram divides the variable values into an equal size of interval. The data that we use in y-axis is frequency, and our x-axis is class boundary. The class boundary of 99.5, we have a frequency of 4. This graph that we use in quantitative variable, our graph and frequency polygon. The y-axis, we use the data of frequency. Our x-axis, we use the data of class mark. The class mark of 175, we have a frequency of 4. In 326, we have a frequency of 10. In 477, we have a frequency of 8. In 638, we have a frequency of 2. In 779, we have a frequency of 0. In 930, we have a frequency of 3. In 1081, we have a frequency of 0. In 1232, we have a frequency of 0. In 1383, we have a frequency of 0. In 1534, we have a frequency of 3. The first graph that we use in quantitative variable is ogive. An ogive, also known as cumulative histogram, is a graph that is used to determine the number of data points that are equal to a certain value of dataset. In our graph, in y-axis we have a cumulative frequency, and our x-axis we have a class boundary. The class boundary of 99.5, we have a cumulative frequency of 4. In 250.5, we have a cumulative frequency of 14. In 401.5, we have a cumulative frequency of 22. In 562.5, we have a cumulative frequency of 24. In 703.5, we have a cumulative frequency of 24. In 1005.5, we have a cumulative frequency of 27. In 1156.5, we have a cumulative frequency of 27. In 1307.5, we have a cumulative frequency of 27. In 1458.5, we have a cumulative frequency of 27. In 1609.5, we have a cumulative frequency.
Her qualitative table of what do fish vendor usually do with their income in a day. The class here does food, student allowance, fare, savings, rent, ice, grocery, and gasoline. The food have a tally of 25, and the student allowance have a tally of 14, and the fare tally of 7, and the savings tally of 1, and the rent tally of 1, and the ice tally of 6, and the grocery tally of 6, and the gasoline tally of 1. In the frequency, just convert the tally into a number. Frequency divide the number times 100. The food have a 25, and the fare have a 14, and the savings have a 1, and the rent have a 1, and the ice have a 1, and the grocery have a 6, and the gasoline have a 1. The percentage of food have 41%, and the percentage of student allowance have 27.95%. The percentage of fare have 11.5%, and the savings have 1.63%, and the percentage of rent have 1.63%, and the percentage of ice have 9.63%, and the percentage of grocery have 1.63%, and the percentage of gasoline have 63%, total of 100%. Her
Now, let's proceed to categorical frequency distribution. Bar graph has two types, horizontal and vertical. Let's discuss first the horizontal. A bar graph is a chart that uses bars to show comparisons between categories of data. The x-axis will describe the types of categories being compared, and the y-axis will have numerical values to represent the values of the data. We questioned 30 respondents about what they mostly do with their income in the day. Mostly of them answered food, next is student allowance, followed by fare, then ice and grocery, and the lowest was rent, savings, and gasoline. Now, let's proceed to vertical bar graph. Same data, same interpretation, but the location of the class mark was in the y-axis, while the numerical values was in the x-axis. Next is pie chart. Pie chart is divided into sectors, where each sector shows the relative size of each value. Mostly of them answered food. Next is student allowance, followed by fare, then ice and grocery, and the lowest was rent, savings, and gasoline.